Is this supposed to be bigger?
관종 됐네.
Yes, it's a hint. Here is hint.
준이야, 이거 내 거야? 가방에 넣다 놔줄 거 아니야?
야, 그거 물 얼마나 남아있어?
물? 많이.
좀만 더 마셔, 이거
귀찮아. 안 마셔.
그렇게 끝내주기 잘하지.
나 좋은가 생일 신경 받고 있어.
아이고.
몇 개?
내가 일본한 너 아니야.
Could I write it like this?
No.
Is this okay?
It's really vague. My point is time is bigger and longer than that.
It's longer?
Yes.
longer is very
Is this anything to do with it?
No, there is no C.
Is that anything to do with it?
There's no C in there. I think you almost saw it.
Is this C? Do I need to say C?
I don't know.
I feel like that has something to do with it, that there's no C. C is missing.
Yes.
뭐지?
I will not say.
안 풀어줘. 인수분해가 다 됐는데 더 되면
인수분해.
또 루킹.
예수분이 is.
또 루킹. 저기요?
Time to see?
뭘 보시려고 그러는 거예요?
What?
풀어보게.
아니 이게 인수분해가 안
Oh, you almost got it.
Time to see?
이거 있네.
네?
Time to see or something?
No. It is, but it is similar.
EXY를 인수분해하고 X제곱 플러스
이거 합고치잖아 합차.
합차잖아. 그래.
했는데
그래.
이게 끝인데 더 있대.
Okay. 질문.
Teacher. 이거 인수분해예요.
어쩌고.
Factor.
벡터.
아, 팩터잖아.
Factor. 뭐?
this.
질문도 많이 해주세요.
What? I'm very sad. 합차 플러스 앤 마이너스.
Is this right?
잘 들어왔네.
이거 됐어.
아니 이거 해야 돼서.
오케이.
아니 했는데 다시 아니래. 합차인데.
Time above C. 어떻게?
강제는
Time without C?
No.
Time what is it?
I know you can.
Long time no see.
Yes.
오.
Wow.
아,
너무-
풀었어.
Long time no see.
와.
Because the
long 근데
yes,
long
long.
아니고 그냥 크다. It's just
Long.
big.
Long time no see.
I see. No, C, but this is a punt. So this is C.
I see.
지고 있잖아. 손 앞에.
Okay,
Interesting.
we get it. I got it. Told you, don't tell me the answer because eventually,
Yeah.
at some point, it's like that with math. At some point, you see. Okay, so we have to factor this horrible thing.
Oh my God.
I don't want to. Okay, what is that right?
Yes. 시절.
What?
마이너스인데 이거.
Minus?
no. G 제곱.
Minus E
Yes.
squared?
뭐야?
아, 원래.
나도 했어. 야 합정해서 해가지고 했는데 답이 아니래.
I will do it.
This is 2xy squared minus x squared plus y plus z times y minus z
Oh no.
squared.
Don't do that.
Right? This is right, right? Everyone agrees on this. Because this is
두 개 있잖아. 봐봐.
Square, 2 square,
어.
x square, y square, 2xy square.
아.
And then this is simple to put in y plus z times y minus z. Okay? And then I don't know what else. Oh, I see. And then this becomes A and this becomes B. Yeah, and then you get 2xy plus x squared plus
X
y plus z times y minus z.
오.
And then that times 2xy minus x squared minus y plus z
오.
times
어, 너
y minus z.
네 개야 항이.
답이?
네 개야 너.
음.
나는 이거
이거
찢었어.
맞아요.
쌤 답을 보세요.
그러니까 맞긴 한데 그냥 이게 답이 아니고.
아,
You
근데
have to one more factor.
What? So they want you to factor again?
아닌데?
Oh, because you can pull an x out, so it's.
쌤 거기까지 맞나? 맞는데?
맞아요. 이거
그거
다
그거지,
맞아요.
알파게.
아니.
근데 you can pull an x out of
샤프.
here, so it could be like.
아니 여기서 완전 제곱이 나와.
이걸
맞아
x
맞아.
times 2y plus 1
사람마다 기준은 다르니까.
완전
plus y plus z times y minus z
No. 이렇게 안
이거
나와요.
맞아요.
Teacher. 맞다. 은혜.
What form do they want?
First 처음에 잘못했어요.
응?
처음부터.
아니 잘했어.
그러니까 이거를 하면 안 돼요. 이거를 안 하고 이렇게 만.
But this is right.
아니 너무 빨리 했어요 이걸.
응?
그러니까 이거를 이렇게까지 잘했어. 그러니까
와,
이거잖아.
빨리 했다는 게 뭔데?
아니 이거 맞아요.
이거잖아. 이렇게 해가지고. 아닌데? 이거까지 이렇게 해가지고
근데
완전 정식 나오는데 이게
그거
안쪽에.
근데 이거
Yes, 원. 이런 풀이 과정 안 쓴다고 이걸. 여기 답을 풀이할 때 내 걸 봐봐. 아니 억울해. 왜 물어보는
제 책이 이상한.
이거 더 좋아요.
예.
다 팩터니까.
티처.
아이고.
답. 나 안 사용해요. 여기서 사용해요.
줘봐 한 번. 어디야?
이거
불가성 나.
이거.
I will get same answer. You get the same answer anyways.
답 쓰고 하는 내 스타일은 아닌데 답 보고 하는 건 내 스타일은.
아니 근데 이거 또 I don't know.
응? 뭐야 먹고 이게?
나도 몰라. 그렇게 나와.
그냥 합창공식이잖아.
그러니까 합정식 나중에 한다니까?
아니 지금 여기 봐 처음부터 합창공식 쓴 거잖아 이게.
그러니까 처음에 합정식 한 번 더 쓰고 나 완전 제곱식으로 한 다음에 합정식 따로 하는 거야.
워터포.
뭐지?
워터포.
응?
아니
알았다.
알지?
몰라.
그러니까 처음에 합정식을 만들고.
아니 근데 이거 어디서 만든 거야 이거? 문제 신상 싸구려네 이거.
Oh, so it wants me to write it like because this is squared. Wait, so it wants you to write it like this? Does it want it like 2xy minus x squared plus y squared minus
Yes.
It wants it like this?
Yes.
Oh.
It's terrible.
This is stupid.
Yes. Why don't you do stupid math problem
This
in
is
high school?
useless.
Yeah.
I never
우리
use
이거
this.
해보는 게 잘못인가 봐. 이 책이 안 괜찮아.
This is the
합정식 생각했잖아. 그다음에 이거 완전 제곱식이 되잖아 이걸로.
지금 하고 있는데? 하고 있잖아. 다 잘 되고 있잖아.
쌤 잘하고 있어. 근데 준이가 이해하고 있어.
아까 근데 그거를 왜 물어봤어?
그니까.
그러니까 그냥 궁금했는데 답을 보니까 답이 이게 아니잖아. 답은 알아. 근데 풀이 과정이 왜 그렇게 되는지 궁금한 뿐이야. 그러니까 답 보니까 알고 있는
사기다
거잖아.
사기. You crook.
Oh, I see what they want you to do.
아하.
I get it, yeah.
와.
So it's it's x minus y. Cause this part here is x minus y squared.
어.
Yeah.
어.
And then that's. I mean, sorry, y minus x. My bad.
응. 알죠.
Or you could write it. I guess you can write
저렇게
it.
한다고?
그렇게 보여.
뭔?
No. This is
Stupid.
It is x plus
제목도
y
얘기를
squared.
하면서
no because this is a minus.
아.
내가 답을 알아. 왜냐면 최저부터
This is minus, so it's minus x squared minus. So it's minus x minus y squared.
답이 샘플 보면 나도 그런 거다 보여줬지. 근데 첫째 이득은 아닌데.
Yeah.
Yeah.
아니 왜 물어봤냐?
Yeah.
그니까 풀 같은 거 있다고 그러는데 내가
It has to be.
물어봤거든요.
Because it's minus. It's minus x plus y squared.
Yes,
Sorry,
yes.
minus x plus y squared. I see how it works. Okay. Minus z squared, and then you have times
이제 마이너스 플러스 g
plus z squared. Yeah, and then this is the other way around. This is x plus y squared minus z squared. And then this one, you do a plus b, a minus b, right? So it's like z squared. So it's z minus x plus y times z plus x plus y, which equals z minus x minus y times z plus x plus y. I could have made a mistake. It could be wrong. I don't know if I make a mistake or not. It's very easy to make a mistake. Why did I make you do this? It's so stupid.
Answer this.
I get that. I don't know if it's right. Could be off by a sign.
맞아요.
Yeah, I don't know. Something like that. It could be like this is
상이 또
plus.
빙밖에 안 나와?
I don't know if the plus or minus is right.
It's
But
crazy.
it looks like that. Something like that. It's not important if it's off by plus or minus.
답이 아니야.
We will give up math.
Right? This is not real math. And you never do this. I haven't done this since high school.
But our school have to do so. My school is crazy.
Wait, okay, so what? Did I make a mistake? So then we look and see, okay, it's wrong, you make a mistake. Where did the mistake happen? This a squared minus b squared. I see the problem. Aha. It's this times, I didn't do the other one, I just did that one. So this one, this is where the mistake happens. So it's x plus y minus z times x plus y plus z.
Oh yeah.
저기 뭐야?
There we go.
오 예스.
Yes.
Oh.
이게 제일 쉬운 걸로 낸
If
거래.
there's a mistake and something doesn't look right, go back and you see, oh, there's where the mistake happened.
나는 쌤도 어려운데 난 어떻게 풀라는 거야.
I will give up math.
This is not math. This is just like algebra. This is like easy physics.
너가 잘하니.
More like physics than math. But basic physics.
But in Korean it is math. I'm
No
sorry.
one does. This not even college algebra is different. College algebra is.
알지브라가 누가 나온다?
알gebra 대수학.
대수?
뭐 math is the knife used in surgery.
But to solve these, you can actually use matrix. So you can actually solve like these kind of equations with matrices sometimes. If it's linear, right? If it's not squared. If it's like x plus y plus z plus plus W or something, you can have like a 4x4 matrix.
오.
You know?
토니 몰리.
So that's linear algebra.
I like matrix than crazy one.
This is gross. Okay. Any conceptual
한 개 더
questions?
있는데?
응?
질문이? 지금
똑같은
아직
거야,
쌓여있어.
이건 똑같은 거야?
아니 달라.
다행이다.
뭐가 달라요?
인수분해는 없고 그러니까
come.
그 나머지 정리.
나머지 정리 쉬워 그냥.
이거 어떻게
나머지
설명해?
정리를 이용한 인수분해야 아니면 그냥 나머지 정리야?
몰라. 이거 어떻게 푸는지 내가 어떻게 알아?
아 나머지 정리 영어로 설명 못하잖아.
문자부.
이거
이거를
뭐예요?
일단
이거가 뭐야?
목 하고 땡땡땡.
여기 교과서니?
그렇지.
그거 뭐예요?
이거.
거기는 뭘 알고 싶? 문제
그러니까 문제 이건데 모르겠다고. 나머지 문제는 아니야? 어떡해 준이야. 이제 지금
그 영어로 설명해.
아하.
오케이.
나스필레스뱅이.
맞아.
아유 라이트.
너랑 비슷한 거 같은데 어제 너가.
이거 너무 싫어. 나 이거
너무 쉬워요?
너무 싫어.
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 hate.
이거
Me too. But 매프가 저는
Remain.
어떡해요.
RX, and what is R of 10? R of 10. Each question.
I don't know. Thank you.
X에 먼저.
학교생도 모르겠나? 학교생도 모르겠어.
1
진짜 잘 못해.
넣어야겠다.
너도 풀어야 되겠네, 이거는.
X 플러스 X분이야. 이거 엄청 어려운 걸.
When you divide by this, is it a constant or is it a function?
We don't know.
왜 저를 보내?
How are you supposed to know? Because like it.
잠깐만. X에 1 넣으면은 0이지.
RX가 AX 플러스 B.
안에 0 대입하면 마이너스 1 나오는데.
난 몰라요.
그리고 그냥 0 넣으면
구멍 뚫린 줄 알고 이게 뭐지?
Yeah.
이거 넣어야 되나?
I think so.
Okay. So it's something like this, right?
Yes.
All right. What is this? This is x to the 10 squared minus 1 squared.
Yeah.
Okay. How can we? So we can write it as like x to the 10 plus 1 times x to the 10 minus 1. I think I know what's gonna be happening. X minus 1 squared?
저럴 때 무슨 말인데 이거?
There's some sort of trick, because this is x to the 5. I see, I got it.
Okay.
Okay.
What is?
So it's like if you write it like this, x to the 5 minus 1 times x to the 5 plus 1, and this is the same, because this is minus 1 squared. So it's no, this is no good. How do we deal with this thing? That's the
다
question.
때려넣어서 대입하면 돼.
오케이.
Because this one,
1하고
합정 문제잖아. 여기까지 알아. 거기서 봤거든? 이 합정식 연산하는 것까지 알겠는데 난 모르겠어.
wait, hold on. It's
건강
happening.
안정되다.
I don't know. What? Can I see your textbook?
응?
Can I see how they tell you how to solve this?
it?
No. The reading part. Reading.
해설.
난 몰라.
You learn in class,
아
right?
해설을 보여달라고?
아니 그러니까 답지.
I need to know how they want you to solve it.
이거 왜 이렇게?
eight this. 이거 좀 설명해줘. 왜 있는 거 알아?
Can I just look at
This eight. 영어로
Okay.
Okay.
That's wait, why is ax plus b? What is this?
Because this is
Okay, why? How do you know that R? Okay, they're claiming the difference between theirs and mine is that they claim that this equals ax plus b, and I don't know why it's not.
but
그러니까 차수가
A can be 0 or what? Or
But why can't it be like x squared? Why not? That's my question, because I'm assuming.
I don't know.
I get it.
Oh.
Here's why it can't be x squared. Because if it's a remainder, r of x is less than x minus 1 squared.
Okay.
Right?
Yeah.
그러니까 내가 그 얘기하는 거였다고.
I know, but you don't.
내가 저기까지
Okay, so it has to be some a. Okay, that's what they want you to do. Okay.
내 해석자가 몸을 안
That's
해요.
different. And then they said that you need to wait.
내가 이거 푼다는 거 기적 수준의 기적이.
기적의.
What is that?
Don't know.
I see.
와도 설명 좀 해주네. 이제 멍 때리려고 정신 못 차리죠. 우리 어제 수업을 해야 될 텐데요. 아니 해석은
너네 끝나고 TS 또 해야 돼.
아니 우리 끝났지롱. 오늘 그거밖에 안 했어 우리. 똑같은데 또.
몇 시에 모였어?
So it wants you to
12시
plug
반.
in x equals 1. So it says then you say x equals 1 and then a equals minus b. Right?
에?
Because
What?
you set it to
Yeah,
0.
yeah. If you 그러니까 1 대입하면 0이 되잖아. 그러니까 앞에가 사라지잖아 fx가. 그러니까 다 사라지는데
If
이거
이거 뭔지 모르지.
아니
If x is 1, there's no remainder. Why? Why is there no remainder? So if x is 1.
if x is 1, fx will be gone. Yes.
Yeah.
A 플러스 B가 0인 거랑.
0. If
네,
x is 1,
그러니까
it's
그
0.
그러니까 이항하면 a는 마이너스 b가 되잖아.
So a equals minus b.
오케이.
Yeah. Okay. And then it wants you to do something wacky where it says that you write x minus 1
어떻게 풀는 거? 그거
times
있잖아.
x to the
다른
19 plus
식이 더 있어야 돼.
아하.
18.
왜냐면 이 A, B를 풀어야 되는데 A, B 한 개 보는 거면 한 이거 한
Plus
번 잖아. 근데 이거 보면 C 두 개 쓸 거 아니야.
And I'm not sure why this
그냥 C가 한 개 찾지.
happens because it must cancel out very. I see. And this, all right. So this equals f of x times x minus 1 squared plus, the whatever ax plus b. So minus bx
minus b
plus
plus b.
b. Okay, and the reason why this works out nicely is because
Close out.
you have everything crosses, because there's a plus 1 where the x is, and then there's a minus 1 here, right? So what you're gonna end up with is x to the 20, right? And then if you take this times that, so minus 1, so minus x to the 19, right? So we look at the x to the 19 now, right? So you have minus 1 times x to the 19, but then you also get an x to the 19 from here when you multiply by x. And then that's plus x to the 19. And then you get, what do you get for 18? So you get minus x to the 18 from the 1. Yeah, and then what do you get from here? You get plus x to the 18 from that. And then it goes on. And so these all cancel out. And then at the end, let's do the x term. So from x we get an plus, we get a minus, so we have x right here. So we get an x, right? So minus x, and then from 1 we get plus x, and then minus 1 times 1 is minus 1. This cancels, and then you get x to the 20 minus 1, right? So it is x minus 1 times that, and we have an x minus 1 squared, right?
Okay.
Alright, so then what we do is I think we can divide by x minus 1,
Yeah.
right? Yeah.
Cross out.
Well, yeah, because there's a squared here and then there's that there, so then you get x to the 19. Yeah, so you get x to the 19 plus x to the 18 plus x to the 17 plus x plus 1 equals, I don't know, plus bx minus b equals,
bx minus b.
no, because we have the stupid remainder. Okay. So now what we have to do, that thing, so the x minus 1 times this is f of x times x minus 1 squared. Oh god, why do they want you to do that? So that all cancels out. Okay. What does it want you to find?
R.
R of 10.
R of 10?
Yeah.
Alright, ignore the remainder for 1 second. Hold on.
잘 되고 있어?
No? 난 모르겠어. 응? 응? 묻고. Oh my gosh.
민지도 보고 있겠지?
답 제로 아니야?
제로? 답이? 땡인데.
I got it.
오케이.
Write it like this. Right? Because, okay, so the first thing that we do, right? So we've got this thing where we have x minus 1 times, x to the 19 plus x to the 18
Yeah.
plus x plus 1,
Yeah.
right? And that equals x minus 1. Yeah, do you see?
오케이.
Times f of x
FX를 알 것 같아.
b minus bx. Right,
아니,
okay.
와.
Put this thing over here. Yes.
Okay,
Teacher.
I know.
Teacher, well, a is minus b. So
B minus bx, right? Okay? So then what do we get here? We get x minus 1. Yeah, who knows? But we're gonna solve it, okay?
Okay.
Plus x to the 18 plus x plus 1. But then what do you get here? This is plus bx minus b. Now what is this? This equals x minus 1 squared f of x. Okay, what is this thing? Plus bx minus b.
It remains.
무슨 약간보다 괜찮아.
This is x minus 1 times b.
이거 같아. 이거 앞에가 이거 같지. F가 이거.
Pull the b out. b times x minus 1.
이게.
Yeah, that's what I'm saying. Yeah.
알겠지?
Yeah, and then you cancel. Then you can divide the x minus 1 out,
Oh, that's.
and then you get this horrible thing: x to the 19 plus x to the 18 plus
이거 한 개로 써. 이거
plus x plus 1 plus b. Because we just need to know what b is, right?
Yeah.
Plus b equals What was the other side? Okay, x minus 1 times f of x.
야 설명 잘 못하겠어. 아니 그렇게 대충 알고 있어.
Huh, and then how do you get what b is?
teacher,
Yeah.
and we go to the b to the right,
여기 있는 거 한평 살았어.
and we put x is 1, and we can know b.
Yes, good idea. Yeah, so you put x is 1. What's this if x is 1? This is 20.
20,
Yeah, so you take x equals 1. There's 20. And then this is 0. So 20 plus b equals 0. b equals minus 20.
Operating.
And then you plug in 10. So you have 20 times 10 minus 20 equals 180. Alright, we're done. We finished.
오 맞아요.
Wow.
It's just like you just have to see how it simplifies. Like it's not.
이거 나보고 풀래 학교에서.
You just have to try different things. Like I take wrong steps and then you realize, oh okay, it works out nicely.
Oh no.
There's no easy way. You literally just have to guess. Only way is to just guess. You have to guess, oh, what if I try this? How does it react? I hate that.
I hate too.
This is terrible.
트러블 할 거까지.
Terrible.
We go to terrible school.
I agree.
네 것도 엄마 잘했거든.
뭔 소리?
아니 제 것도 그거지.
You'll never.
문제
This is
없잖아.
so bad.
그거지.
우리도 terrible이라고.
그러니까.
I think it's terrible.
Korean school terrible.
I agree.
답반이 아니야. 우리 학교는 좋았어. 문제 쉬웠거든.
Korean people, but Korean people can solve this in about 2 minutes.
Yeah, very fast. Yeah.
So Korean
But-
stupid. Yeah.
See, it would be better if you spent that time learning to like, solve proof, learn actual problems. You know?
Yeah.
Okay. Okay. So I want to Alright, so I want to review last time. Very important. It's related to your material.
Yes.
So we have binomial coefficients, right?
Yeah. Oh.
Give me an answer and explain why it's right.
X to the n plus n choose
이제 알겠다.
n choose n minus 1.
강의 때 저기.
Or n choose 1.
Oh yeah.
Yes.
Sorry, 1.
Yeah. X y x n minus 1 y plus n choose 2 x to the n minus 2 y square. That's the n choose n minus 1 x to the
Yes.
plus y n.
Alright. And this equals
n.
let's write it as k. What is don't look at your stupid notes. Tell me literally look at this and put it in a sum. Try to put it in a sum. So we've got k is going from 0 to n.
And just k.
Yeah. Right? We've got an n choose n and n choose 0, right? So I guess we probably should have written the 0 and the 0 here and then n here. Sorry. Yeah. Okay. So n choose k times what?
In times x to the a minus k and y k.
Yeah. All right, and these are called binomial coefficients.
Binomial coefficients.
Alright, and so I showed you this thing also, so you realize that this had something to do with Pascal, right?
Yes.
Alright,
1, 2, 3, 4, 5, 6.
1,
2, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 10.
10, 5, 10, 10.
Oh.
10, 10.
No, it's not 5. 5, 1.
okay, and
1, 2, 3, 4, 5.
Oh?
oh, sorry, I got a little off. I need to arrange this better in the okay. 10. Okay, here we go. Now it's right.
Yeah.
And then we have rows.
Raw fish.
It's raw versus row. That's a Korean pronunciation. Row fish. Raw. Raw, row.
Raw is.
And then row is also row.
Wow.
Row is like a fight if you're a British person. So
Lawyer.
1,
Lawyer
2,
is
3,
lawyer.
4, 5, 6, and 2. 제로는 없나?
0, 0, sorry. Yes. 0, 0.
올림피아드.
3, 4, 5.
1, 2, 3, 4.
Okay. If I ask you
Yeah.
for the entry, for an entry ij,
I imaginary.
J1.
no, so usually when we like ask for coordinates, where this is like, a rows, this is I, and this
J.
is the J, right?
Okay.
So J is column, so I equals rows,
Row.
and J equals, this is normal matrix notation,
Okay.
okay? Okay? If I ask you for an entry ij, such that ij equals nth row, kth column, tell me what ij is and why. Well, not why, it's just understanding is hard, but what is ij?
And choose k.
Why? Why? How do you know? Give me an example in the table.
Okay, wait a minute.
Alright, if I ask for, let's say I ask for 4, 3. What's our entry?
4, 3.
Our entry is 4,
Oh yes.
which equals,
X plus y power 4.
the entry is 4, 3.
Yeah.
N row, n equals 4, k equals 3.
Yeah.
The number that we see is,
4 choose 3.
yeah. Alright, if I ask for 5, 2,
5 choose 2.
we get 5, and I go to row 2, 10,
Which is for 5 choose
is it?
3. But the 2.
form for the sum of binomial coefficients, by the way. But I don't like with regards to sum n and k if you fix x and y. So, but okay. So I actually wanted to go back because last time we got sidetracked with this.
Sidetrack?
Yeah, so I wanted to I don't know, okay, we have two options. I can teach you binary today, or we can go back to the domino problem and a similar L-shaped problem.
For this binary?
Either I teach you binary, it's gonna be kind of confusing at first,
Or confusing?
or we go back to the domino problem where you're filling the 2 by n grid with dominoes. And how many ways can you do that?
So the domino problem, I don't know what is domino problem.
It's this one where you have like
이거 까는 거 있잖아.
some 2.
아하. domino.
도미노 피스.
And then I ask you how many ways. To fill with dominoes.
pure 아니겠어. pure n minus.
No, you have to solve again. Okay? So we can go back to this and then try to start another one that I have, which involves a square with L-shaped blocks. So there's one that is about a square with these kind of blocks that I want to talk about. Or we can do binary.
Binary? What is binary?
It's like writing any number
Yeah.
so you write a number n in only zeros and ones. So it's like a representation. So represent n. With only zeros and ones.
It's a mod?
No. So we represent n as a string of zeros and ones. So like for example, if n was equal to 1, 1, 1, I'll tell you that this is equal to 7.
Oh?
Yeah. In binary.
Oh, interesting.
So it's like a different way of writing numbers, and it's usually how computer reads inputs. Equals 7. In binary.
Can you explain again?
So I don't know. I'm giving you two options. We can either go back to this problem and do more strong induction, or we can learn this, but you will be confused.
Then I want to be confused.
Whoa! What?
Okay, the L problem is fun strong induction, but okay. Alright, so basically the way that we write n in binary, right? So if you think of a number, we can think of the powers of 2. 2 to the 0. Etc., right? So what is this?
1,
1,
2,
4,
4,
8.
6.
Okay. Yeah. So basically the way that binary works is you write, so for example, for 0 in binary, what would we write? We would write 0. It's just 0. 0 is 0. 1 is 0.
Okay.
Alright,
영어 아니야?
now, the way that this works is, for example, 2 to the 0 equals 1. So the rightmost place, imagine a grid like this, right?
Oh, I have a question.
Yeah?
For 2 to the 0 means that 2 times 0.
No, 2 to the 0 power is 1. Anything to the 0 power is 1.
응.
That's a definition of math.
0이 아니래.
Yeah.
일이래.
영이 외우래.
You should know that. Okay? That's true. Any number to the 0 power is 1.
어떤 숫자든 들어가 되면 원이 돼.
Alright.
왜
So-
기분 나쁘냐? 되게 내려다 보는 느낌. 알지.
응?
0이에요. 저도 잘 몰라요.
나도 알아 그거는 왜 그런지 모르겠어.
나도 몰라. 왜 그런지.
아니 그래서
나도 몰라.
와 진짜
So it's like we have this kind of thing, right? So it's 2 to the 0. So I'm going to write a number in these columns. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3.
This is why we write from the right.
So this is smaller. We write it to small. We will get there. 2 to the 5, right? And eventually you get to some, 2 to the k, right?
Yes.
Okay. We write this, if I write 1 here, it
Yeah.
means I have 1, 2 to the 0.
아, 네.
If I write 0 here, it means I have no 2 to the 0. Now, imagine these things as like pluses.
플러스.
Our idea is to write n as the sum of some powers of 2. Okay? So it's like for a number n will be equal to 2 to the a1 plus 2 to the a2 plus plus 2 to the ak, right? For some k less than n, right? Okay. So I know it's going to be confusing. But for example, let's take n to be 4. And let's look at our chart. How many of each power of 2 do we have? Well, since n is 4 and k is less than or equal to n, right? We can't have anything more. Or I guess 2 to the k, sorry. 2 to the k is less than n. 2 to the k is less than or equal to n. Okay?
네.
Alright, so what's our maximum number that we can have here for k?
2.
2, right? So we know that all these are out, right? So we're only looking at this part.
그쵸. 2 to the k is equal and smaller than n.
Well, yeah, because if we're adding all these up, why can't 2 to the k be bigger than n? These all sum to n, right? We're writing n is the sum of some powers of 2, right? Okay? So if 2 to the k, I guess like 2 to the a1 you would write, I guess. Because, these power of 2, right? Alright, so say this is the largest power of 2. Right? Right?
Yes.
If you look at this coefficient, which we're calling like k here, why can't this be more than n? We'll come back to this, okay? We'll come back to this. Let's try to figure out how to make 4 from these.
2 to the 0 4 times.
No, because you can't have 4, you can only take 1 or 0. Okay, you can only take 1 or 0 of each power of 2.
2 to the 0 1 time and 2 to the 1 1. No.
So 2 to the 0 1 time, let's take that. So if we took 1, 1, that would give us 4 plus, 2 plus 1 equals 3.
No.
That's not correct.
I think we can't choose 2 to be 0 because it is 1.
Yeah, you can choose 2 to the 0 to be 1. How else do you make an odd number? Oh, you can't for 4. For 4 you can't choose 2 to the 0. But for, okay, if you can't choose 2 to the 0 in general, can you make an odd number?
No.
No, because these are all even.
Yeah.
So you need to have a 2 to the 1. So that's another thing, is that the odd ones will always end in a 1. Okay? Alright, so 4. What is 4?
2 to the 2.
Yeah, so what do we do?
2 to the 2 one time.
And?
No.
What about these two?
No.
Alright, and this is our binary sequence. So we get 4 equals 1, 0, 0.
Oh.
Okay?
Oh, that's.
Alright, let's try another one. Alright, let me give you 2.
2 to the 1.
Yeah, and what about anything less than 1?
No.
No. 1, 0.
Teacher, why don't we? Okay.
Why don't we include any of these? Because then our sequence would be infinitely long. And we get a bunch of zeros to the left, but we don't really need any of them. Okay?
Okay.
Alright, so 2 equals 1, 0, because we have 1, 2 to the 1, 1 times 2 to the 1, plus 0 times 2 to the 0. Okay? Alright, what about 8?
2 to the 3. 2 cubed.
We have 1 of those, right? What about these ones? 0, 0, 0. That's interesting. 8 equals 1, 0, 0, 0. Alright, so what are you noticing about powers of 2? Let's try one more. 16. N is 16. How do we make 16?
2 to the 4.
Yeah, one of those and?
0 then.
Interesting. So 16 is equal to, what are you noticing about the pattern of powers of 2?
0 times 10.
It's a 1 followed by only zeros, right? Okay. Alright, now I'm going to give you an interesting number. I'm going to give you another sequence of numbers. So this is powers of 2. So for 2 to the n equals 2 to the a, we get some 1 followed by a bunch of zeros, right? Okay. Now let's start with 1. What do we get for 1?
1.
And that is
2 to the 0.
1, 2 to the 0. Okay? So 1 equals 1. Alright, let's try now 3. 3.
1, 1.
How do we get 3?
2 to the 1 and 2 to the 0. 1, 1.
Yeah. 1 times 2 plus 1 times 1 is 3. Alright, so 3 equals 1, 1.
눈이 감겨.
Alright. What about 7?
알겠다. 1, 1, 1.
1, 1, 1.
Why? Explain why. Yeah.
2 to the 2 and 2 to the 1, 2 to the 0.
4 is 2 to the 2.
4
1
plus
times 4 plus 1 times 2 plus 1 times 3.
그치이기 때문에.
Yeah.
7 equals 1, 1, 1. What about 15?
알겠다.
1, 1, 1, 1.
Yeah. 8 plus 7. 15.
15.
Okay. Alright. Alright, tell me, which sequences are all ones? N equals say? Let's see if it's just an odd number. Let's give n equals 5.
1, 0, 1. 네.
But that's no good because you got a 0. So, what do these numbers have in common? What numbers produce sequences that are only ones?
2 to the something minus 1.
Yeah.
Okay.
And why is that? So, let's think about what's happening here. We know that 2 to the a is a 1 followed by a bunch of zeros. Now, what if you subtract 1 from that? What happens? Our sequence is growing like this, right? So, what happens? Okay, yeah, I give you a sequence of n1s, right? Right? I give you a bunch of 1s. What happens if I add 1 to n? N equals this in binary, right? What happens if I take, so the n equals this. What if I take n plus 1?
1.
Well, no, because what's happening here? First of all, what's the rule? Odd numbers end in end in 1. What about even numbers?
0.
Yeah. And why is that?
Because 2 to the 0 is 1.
Yeah, and there's no other odd number. These are all even. This is the only odd one. Okay? So this changes the parity.
Parity.
Right? Okay. So, if I give you this, n equals this, and I ask you for n plus 1, what's happening here? So what I want you to think about is like, you know when you do addition? So,
Addition,
you know when you do addition and you carry stuff?
special edition.
So it's like, imagine it this way. So, okay, let's take my 5 ones. And then I write plus 1. 1 plus 1 goes to 0. We don't have 2, so it goes to 0 and you carry 1.
What?
Yes, because we don't have anything but 1 and 0. We only have 1 and 0.
Did you put why 1
This
plus
is
1
bigger.
0?
Yes, because 1 plus 1 equals 2, but 2 does not exist. So we get 0 and we carry a 1.
So
like computer.
Like when you do addition and you have like 54 plus 37, right? And then you do 4 plus 7, because we have base 10 normally. This is base 2, we normally have base 10, so this is 1 and you carry a 1 because it's 11.
it's like a mod.
Yeah, it's like a base 2 because normally we're in base 10, but we're going to base 2, right?
It's like if we 55 plus 55 and 0 and
Yeah, so think about it this way. If we have 1 in binary, 1 equals 1. 1 equals 1. What if I tell you to add 1 plus 1? Then I get 0, and I carry the 1, so I get 1, 0 equals 2. Remember, because 1, 0 is 2.
1 0 is 2.
Yeah, because we have 1, 2 to the 1, and 0, 2 to the zeros.
Yes, strange.
It's weird, I told you you'd be a little confused. Okay?
학교에서 썼는데 저거 할 수도 있다.
So it's like, you can't have a 2. If you get a 2, then you just carry over to the next power because it's by powers of 2. Right? So we're adding 1 to 5 ones. And what did we get here? So we got 0, and we carry the 1. What happens here?
0.
And then,
0 0 0 0 0 0
0
1 0 0
0
갑자기 원이
Alright.
나타나요.
Now, let's think about this. This is 2 to the a, right? So this is 2 to 0, 1, 2, 3, 4, 5. This is 2 to the 5 equals 32, and this is 31. Because, okay, here's 2 to the 0.
Yeah.
This is 2 to the 0. This is 2 to the 1. 2 to the 2.
Yeah.
2 to the 3. 2 to the 4. 2 to the 5. That's our only one. What's 2 to the 5?
Fifth is 32.
Yeah. So that's 32. Okay?
Yeah, okay.
Okay. So we've noticed some characteristics. 2 to the a, minus 1, all ones. We add 1 to that, we get 2 to the a. It's just 1 of this big 2 power over here,
And all zeros.
and then all zeros because it's just 2 to a power. Odd numbers end in 1, and because when you add 1 to an odd number, you get a 0, even numbers end in 0. Okay?
Yeah.
So I want to ask you guys some questions now about numbers in binary, because you need to get used to it. Okay? So basically we're representing the number in base 10. Base 2 instead of base 10. So if you look at like another way to think about this is if you look at like the normal numbers, what do we have? We've got like 1, right? And then we have 10. And then in between we've got 2, 3, 4, etc. And then we have, 11, then you have 20, right? 30. And then what happens when you get to 90? You get, we add and then we get 100. Right? It's working the same way in binary, except it's just going by 2's, because in everything we only have 1, and then we have 0, right? So we have 1, and then we have, 1, 0, and then, you can go to 1, right? So you have 1, 1. But then when you get another 1 here, nope, you need to make more space, and then you get a 1, 0, 0, 1, 0, 1, right? Because you can go 1.
Wow.
Okay, so the way that this is working is like 11, 12, etc., right? To 19. And then when you reach a 9, you go to the next one here. It's the same in binary, except when you reach a 1. Okay? It's just 0 and 1. There's only 2 things you have instead of 10.
Yeah.
So it's 1. Okay. Then we add a 1. So we go to 1, 0. Right? Oh, okay. We can add a 1 and we get 1, 1. Okay, we're good, because we can add a 1 here. But then the problem is that when we add a 1 here, we need to make more space, because we've hit a 9. Alright? 1, 0, 1.
1, 1, 0.
1, 1, 0. Because this one can go here, right?
1, 1, 1.
1, 1, 1, and then you
1,
get
0, 0, 0.
yeah.
Okay.
Alright. So that's a useful way of thinking about it. I'm going to give you some random numbers and ask you to write them in binary. I want you to do 62.
52?
Oh my god.
N is 62?
Yep.
2 to the 62.
No, n equals 62.
There is N or H.
N.
N?
n equals 62.
H 아니야?
그럼 뭐.
선생님 그냥 살짝 알아보기 힘들어. 네가 6학번.
Okay.
2 to the
It's not that.
6 minus 2?
Yeah, okay. That's a good one to, okay.
보이는 이유는?
음.
아 너무 이상한 거 같았어.
와.
누구 때문에?
어? 어? 아, 2 to the 6 minus 1 is 1, 1, 1, 1, 1.
How many ones?
아, 6. 6 1. No, 5 1.
6 ones. Yeah, I think it's 6 ones. Why? Alright, so let's write it out. Let's write 2 to the 6 minus 1. Okay. What is that? So we got a 1. Alright, so let's see. What's the biggest power of 2 that's smaller than it? What's the biggest thing we can take? We can't take 2 to the 6 out. Doesn't work because it's less, right?
6 to the 2 to the 5.
2 to the 5. What's that?
It's 32.
32. Alright, cool. Now let's subtract 32. 62 minus 32 equals
30.
30. Alright. So yeah, we can take one of these. Now what's the biggest next biggest power of 2 we can take? Can we take 16? Is 16 okay?
No. Yes.
Yeah, 16's okay. So we get plus 2 to the 4, right? 16. So 2 to the 4 is 16. Alright. Now we take 30. We have 30 left.
Yeah.
Minus 16.
14.
14. Alright.
Two
What's
to
the next one? 2 to the 3 is 8. Is 8 less than 14? Yeah, we're good.
Yeah.
Alright. Alright, so 14 minus 8.
6.
Yeah, okay. What's the next power of 2?
2 to the 2.
And that is 4. Is 4 less than 6?
Yeah. 2.
Yeah. Alright. So 6 minus 4 equals 2. Alright. And what's the next power?
2 to the 1. Is 0.
Sorry, I meant to do 63. I'm literally an idiot. Yeah, so, yeah, this is fine. Minus 2, yeah. So this is 2, now we have 2, yep, and 2 to the 1 is 2. 2 minus 2?
0.
What does that mean about our last place? Can we take 1? 2 to the 0 equals 1. Is 1 less than 0?
No. Yes.
Yeah. Plus no 2 to the 1. Plus 0 times 2 to the 1. So this is 1 times. 1 times, right? 1 times, 1 times, 1 times. So what is our binary sequence? 2 to the 6 minus 2 equals 1 times 2 to the 5. Alright, so what's our rightmost place? We've got a 0 times 2 to the 1.
Yeah. 1.
1 times 2, 0 times 2 is 0. 1 times 2 to the 1.
Yeah.
1 times
To the
2
2.
squared. 1 times 2 cubed.
Yeah.
1 times 2 to the 4th.
Yeah.
1 times 2 to the 5th.
몰라.
Do we have anything else?
그거 처음
No.
썼어.
Yeah.
When you solve the problem, you said 62 minus 32 equals 30, and what does that mean?
It's because we're trying to find 62, right? So I want 2 to the a such that, like, 2 to the a less than or equal to 62. And I want this biggest possible. Right? I want to find the biggest possible 2 to the a that's less than 62. Now, what's the biggest possible 2 to the a? What's a?
5.
A equals 5. Because 2 to the 6 is 64.
이거는
So it's too big. It's too big. So you need 5. And 2 to the 5 equals 32.
Yes.
So we take 1 times 2 to the 5, and then we subtract it from our whole thing. Because we already added 1 times 2 to the 5 here. And then we repeat. We look again, we say, oh, we have 30 left that we need to make.
이거 아까 쌤 얘기해준 거 이거 있잖아. 이거보다 작은 게 이게 5잖아. 최대 작은 게. 그럼 우리가 또 30을 구했지. 이것도 이게 최대로 되는 기분이야. 4잖아. 이거
Why we have to 1 times 2 to the 5?
Yeah, because I wrote 1 because we can only take 1 or 0, right? Our option is 1 times 2 to the a or 0 times 2 to the a, right? So we take a 1 because we can. Because it's less, it's okay. Okay? If it's still less than it, we take 1. If it's not, we take 0. It's too big. If it's too big, we take 0. Okay? I do another example and you'll start to understand. Okay? Alright. Let's take a random number. Alright. Let's take 41. Alright, let's see. Let's write 41 in binary.
2 to 3.
Alright, what's the largest power of 2 less than 41?
2 to the 5.
2 to the 5. Okay,
Yeah.
equals 32. Alright, so we take 1 times 2 to the 5. That's the first one. The first digit's always a 1. Okay? Alright. And then what do we have? Okay, so 41 minus 32 equals 9. Alright, what's the next power of 2? 2 to the 4.
No.
Can we take that?
No.
No, it's 16. So we have to take plus 0 times 2 to the 4.
Oh.
Because you need something smaller. Okay, what about 2 cubed?
Yes.
Yes.
Yes, it's 8. 8 is less than 9. So, plus, we'll take 1 times 2 cubed. Alright, and then we have 9 minus 8 equals 1. Alright, what's the next one? 2 squared. That's
No.
4.
No.
Yeah, no good. Alright, 4 is no good. So plus 0 times 2 squared. Alright, what about
2 to 1.
2 to the 1? What's
No.
that? That's 2. That's still too big.
Yeah.
0 times 2 to the 1. Alright. And what's our next one? 2 to the 0 is the last one.
Yes.
Yes.
1.
Yes, 2 to the 0 equals 1. And we want to get 0 at the end. Because if we don't get 0, it means they don't add to the number that we want to make. Okay, it should be 0 at the end. 1 times 2 to the 0. Alright, so let's look at our coefficients. 1, 0, 1, 0, 0, 1. So we write 1, 0, 1, 0, 0, 1 equals 41. Okay?
Computer is 41 like that?
Yeah.
Oh.
Actually, it can be helpful to like translate strings into binary because sometimes it like takes up less space. So, and also it's very useful to think about it like, oh, if the computer reads a 0, it goes this way. If it reads a 1, it goes that way.
We can express any number using 2 to the something.
Yeah, exactly. So why do you think you can express any number?
Because there is 2 to the 0, which we can change the parity.
Alright, so it has to do with this very nice fact that the sum of the powers of 2, right? So so if you write it like this, I think, sorry, let's write n minus 1. And so what this means is that for any I, you can always make 2 to the n minus 1. Why is this good? Why is this very helpful? So this means that like, okay, so for example, it's like, 2 to the 0 plus 0 plus 2 to the 1 equals
3.
3. So you can make the powers of 2, right?
Yeah.
Then you get 2 to the 1 plus 2 to the 2 minus 1. Because you can take minus 2 to the 0, right? So it has to do with this thing where if you take the plus and minus combinations, you can make every number. Okay? Alright. It's hard for you to understand that. Alright. So we can express any number in binary, right? Or a program even, or something, So a lot of times, like, you'll see, like, graphs and networks. It's like, the computer will read some sequence in binary, and then it'll do something. Okay? Alright, I want to give you one more example, and I want you guys to solve this one on your own. So I'm going to give you, write 86 in binary. And then I'm going to ask you a conceptual question.
What is binary?
What we've been doing. 1 0 1 0 1 0.
Binary is computer number.
Is base 2. So it's like, if you think about it, our normal numbers are base 10, right?
Yes.
Binary is base 2.
Wow.
You could do it like with other bases also. It would just be like, say if it's, it's sort of like mod. It's sort of like mod. But a little different.
62가지고 64.
Oh my god.
62, 64.
Oh my god.
Let me write what I get, and you're not gonna look at it.
원 제로 원 제로 제로.
Hold on.
벌써? 마지막 이거. 이거 제로 제로. 에? 여기 하나. 여기서 원 제로 원 제로 제로. 아이고 아니야. 뭐 이러지?
I think it's this.
나 0까지 있지. 어쩐지 이상하다. 방 터진다. 이거 2,000원이야. 신입생은 오늘 좀 길러야겠어. 근데 그 몸 안 떴어. 눈 잤으니까 좀 챙겨야 돼.
원?
아니 놀리지.
왜 원이야?
이 4이 나오니까 2를 다시 없애줘야지.
아니 아까 영 하는 거는 무슨 뭐 안 더하는 거라고 그러지 않았나?
무슨 소리야?
응?
다 써줘야지.
원줄.
아까 마지막에 쌤이 뭐 안 더했는데 여기서?
응?
아, 원제로.
마지막 거 더해야지. 2 to the 0.
왜 그런지. 아니
I have
여기에다가 막 그거 안 더했잖아
I have this.
What? Really?
이거 안 더했잖아.
그거 잘못한 거 원래 해야 돼. 네.
Yeah.
마지막에 정한 전.
Yes. Drawing. Of course.
아까 왜 쌤이 안
And
됐지?
it adds to 86.
왜 안 됐어 아까? 쌤이 있어요. 왜?
Dude, what 8 plus 6?
80, because this is 80, right?
안
There's
된다고
64, because 1 times 64 plus 1 times 16
Uh-huh.
plus 1 times 4 plus 1 times 2, 80 plus 6. Okay,
Hooray.
one more. One more, just so you're used to it, okay?
Yes. I think it's interesting to find the number.
You are very free.
It says
아,
나쁘지 않아요.
let me use the binary.
Yeah, in computer.
Computer
reads binary. So a lot of times, like, your input for a computer will need to be converted to binary. Because that's how the computer reads it. 121.
What?
Okay, did you get this for the last one? What did you get for the last one?
Same, sorry.
괜찮아. 우리가 좀 틀렸어, 내가. 계산.
아, why?
들었어?
열심히 했는데.
I mistake. figure out.
아, 힘들어. 아까 다 했다 하셨죠? 그 부분 백과사전 같은 거. 뭐 답이 왜 그래?
테니스.
와 테니스?
응?
여기 테니스 선수가 있어.
아,
Really?
아, 와, 네.
Either you like to watch tennis game?
왜?
Yeah,
이게
I mean, since Corona, I don't watch as much. But,
Not right, Nadal.
huh?
Nadal.
너도
스페인.
봤던 거지.
아, 맞아, 파리.
I used to watch a lot, yeah. I've seen him play. I have a picture with him.
I'm angry.
Oh, really?
Yeah.
Because
Oh.
Oh,
In New York, randomly.
yes, you saw it too.
I have
Huh?
yeah picture with Federer and with some other players.
Oh,
But
really? Oh.
yeah, not Nadal sadly. I wanted one with Nadal too. I hate him.
이거야?
He's a terrible person.
와.
성격 못했어.
Oh, yes.
아, 그럴 수도 있죠. 못된 사람이 여기 얼마나 많은데.
팔 있구나 진짜.
I'm crazy. 아.
They all like I hear they like I know some people who like know people and like they you know like Nadal, Federer, like Murray even they're all nice and then Djokovic is just mean.
Yes.
Bad person. He also does bad things.
아까 로봇 시작하는 거 같아.
But he wants everybody to like him.
뭐 바보
He wants people to like him, but they don't. Sadly.
When do you meet him?
Djokovic, I don't meet him, but I know people who know.
Federer.
They're in New York, like
New York.
7 years ago.
New York Open tennis.
U.S. Open.
Yeah.
But it wasn't at the tennis court. I saw him near Central Park.
Oh.
Yeah, he was getting in a car.
Oh.
Yes.
And you
Yeah, he offered to take it, but I did. I was very young. I was like 14.
high school 14.
15. I was 15.
15? 와.
난 진짜 창문 열어가지고
Yeah.
Oh, I heard that when Justin Bieber was in car and a person wanted to shake hands with him, but Justin Bieber hit him.
Okay, but that's different. Because Bieber, the thing is, Bieber has a bunch of crazy fangirls. That's totally different. Because the people who see Feder, it's not like your average person is going to be like chasing after Feder. He doesn't have people following him around.
채국 씨한테 댄스가 싫으면.
No, it's like Justin Bieber, he has a bunch of like crazy girls, like they will literally like kill him.
He said that
뒤까지.
Yunja said he is in jail now.
He is in jail? I don't know if he's in jail. I don't think he's in jail anymore. No, I mean, yeah, he got caught many times. They all do it. Hollywood is everybody. But he also is just like that for a long time.
bad person. He's only good at singing.
He's not good at singing.
Huh?
No, he's not good at singing. He's just, I don't know. He just, you know, like when they take like the little teenage kid and they're like, oh, girl will like this. Okay. He's not even good at singing. He just used auto-tune.
Oh, really?
Of course. They all, okay, everyone uses auto-tune. Everyone. Okay.
그래서 창문 노래 표준 엄청 많고.
Okay, everybody uses auto-tune, but some people they sound good without auto-tune and some people they don't. So even like, you know, they may use auto-tune, but then you hear it live. Like Lady Gaga, I went to her concert like a while ago. She's a very good singer actually. She sings very well. But then other people like Katy Perry, she cannot sing. Her singing is bad.
Then
Everyone uses auto-tune while singing.
What?
she used
Auto-tune. Yeah. No, everyone.
I think Eminem doesn't use auto-tune.
Because he's rapping, he's not singing.
Oh, but in Korea there are many rappers in Korea, but some of them use auto-tune, such as 창모 or blah blah blah.
난 몰라.
Famous in Korea,
난 몰라.
들어보면 알아.
then why they're exist singer because they use auto-tune and
Well, it's like developed because technology developed.
and all people can sing like him or
So some people they sing very well live, and some people they're really bad live. But they all use auto-tune regardless of whether they sing well. So people who sing well also use it. But then when you hear them, they're good. But then like some people they use it so they sound okay, and then you hear them and they're so bad.
Face and body.
But it's like everybody knows who sings, like everyone knows who sings well and who doesn't. It's like everyone knows. Because people go to the concert and then they can hear and they say, oh.
concert can't use auto-tune?
No, because how do you sing live with, you can't sing live with auto-tune. You have to sing unless you lip sync.
그러니까 정확하게
auto-tune이라는 거, 음성 변조하는 거. 그러니까 마이크로 부르면서 즉석으로 할 수 있고, 애초에 부른 다음에 편집하는 것도 가능한데 보통 즉석으로 많이 하더라고. 그래서 막 가끔씩 옛날에 내가 봤던 K-pop 하시는 사람도 막 유튜브 방송하면서 막
근데 콘서트 가서 할 수 있잖아.
할 수 있지.
근데 왜 안 하는 거야? 근데 왜 안 돼?
뭐가 안 돼? 된다고?
안 된다고.
얘는 거 배꼽
안 된다고? 뭐가 안 돼?
Alright, I got
라이브로
this.
부르면 그렇지. 사실 오토튠 안 쓸 거야.
됐어요?
대부분
아니다.
틀렸다.
Why?
저 아니지 않나?
뭐야?
Teacher, no.
No.
아 맞아요? Did I make a
No.
mistake?
Yes.
No. Where is my mistake? Tell me.
어.
64.
11111001.
Yes.
맞았어. 우리도 그거야.
Wait.
왜라니?
No, cause it's
Teacher, 120, 121 minus
It's
64.
맞아.
And it's
32, 64, 32,
Yes.
106, and 121 is 15. 0.
so,
응?
eh?
아.
No, 25. 25.
Ah! No?
25.
96. My bad.
Yes.
Yes. Good catch. 25. Yes, so then we have 16.
와우.
See, I make mistake too.
Weird.
16 and then 25 minus 16 equals 9.
9.
Ah, yes. So then we have another 1. And then we have a
And 001.
아, 다시.
0.
미끄럽게 만들지 말라고.
Yes. Good. You
Yes.
fixed my mistake. Good job.
Great job.
Okay.
야.
So, my next question
아.
어?
is
이지한 걸로.
how many bits?
Bits?
뭐 이지?
So bits is digits, right? In binary digits, we call this is like 1 bit.
비지.
아, 몇 비트? 8비트 이런 거.
Bits.
막
비트?
Bits.
비트박스.
No!
비트에 과일 야채소에 비트 있어. 그치? 자도색이 좀.
너 설마 그 무 말하는 거지?
맞아.
와, 세상에.
그거 갈아 먹으면 맛있어.
Oh no.
뭐한테 좋아. 너 먹어봐.
싫어.
유지성이 학교에 그거 싸들고 다니던데.
학교까지 너무 쪽팔려서 못 먹어.
Okay, binary representation, it's just this thing, okay?
아, 오케이.
So how many bits is how many digits, right?
There is 7 bits.
제일
So
큰
this
게
is asking,
뭐냐고요?
yeah, how long is it? This is 7 bits.
그러니까 저기 제일 많은 게 뭐냐고 비트가? 수에서?
Give me it as a function as n. Here,
For example, 101 is 3 bits.
yes.
그래서 그렇게
이거 모르지 않나?
이거 찾으니까.
저거 어떻게 찾아? 잘해서 불러야겠지.
Consider, so my hint is consider n as a power of 2.
Okay.
So first do if n equals 2 to the a, how many bits? First do that. Then tell me for the rest.
펀시션?
As a function of n. So in terms of, ignore that for now. Ignore that for now.
저 펑션이 함수의 펑션이 아니고 기능의 펑션.
Just say n equals 2 to the a. Okay? How many bits?
Many bits.
We can give an example.
Alright, yeah, work through some examples. Try examples, then you get an idea, right? So if n equals 2 to the a, what is n gonna be? It's gonna be some 1, 0, 0, 0.
very big.
Right?
머리가 안 돼.
there is.
무한. 무한. This.
생각해봐.
This. N.
This level.
뭐예요? infinite? 아니, 그게 아니고요.
This cover bits.
답이 없어요.
답이 있어요.
답이 없어요.
n equals 2 to the a.
2 to the 1, 0, 0, 0, 0.
Alright, let's try, okay. n
그냥
equals 2 to the 0.
말이 돼.
How many bits are there?
1 bit.
1 bit, right? Because it's just 1. Alright, so n
plus 1 beats. No?
Close.
n plus 2 b.
No,
N plus
not
one.
n, not n, not n. N is 2 to the a.
아, a plus
Yeah.
1 beats. Oh, you got it.
Alright, how do you know though? Why? Tell me why.
이렇게 이렇게 할 거 아니야? 1 아니면 0 아니면 한 칸에
and
1 아니면 0
six.
들어갈 거 아니야? 이게 무한이잖아.
There is 7 beats.
어떻게 구해?
Yeah, so here's the reason why. So if n equals 2 to the a, right?
Yeah.
We've got here is 0, right?
네.
We've got 2 to the 0, 2 to the 1.
무한.
Alright, here's 2. Alright. And n equals 2 to the a. So this is 2 to the a, right?
Yes.
This is 2 to the a minus 1. 2 to the a minus 2. 2 to the a minus 3. But, so we have a here to 1 plus 0. So, a plus 1 bits.
Yeah.
Alright.
이거
여기
If
있잖아 마지막에.
n equals 2 to the a.
완전제야.
왔는데 여기까지 있잖아. 여기까지 줘야 돼.
완전제.
뭔 말인지 모르겠니? 그러니까 0부터 2까지 숫자
Because you need one of the 2 to the a, right? The biggest power of 2 is the 1.
When?
Then the rest are 0.
이거
But you
아니,
need
아니,
every
좀
power of 2 less than a.
Yes.
Yes.
그러니까
So what?
So,
그러니까 예를 들어 그러니까 이거랑 이거의 개수 1부터 3까지 어떻게 더해? 그러니까 3에서 1 뺀 다음에 플러스 1을 하는 거야. 그러니까 4에서 1에서 4까지는 4에서를 1 뺀 다음에 플러스 1을
Alright,
하는 거고. 예를
now
들어
generalize.
그러니까 4에서 2까지 하면 2에서
For
4까지
any n.
하면 4 빼기 2를 한 다음에 더하기 1을 하는 거야.
베리베리 어렵다. 오케이.
No, it's not.
2에서 4까지 가면
베리베리
아니,
어렵다.
Very, very difficult.
사진상 몰래.
아.
Very, very
그러니까
difficult.
5에서
아,
10까지
해봐, 해봐. Very,
와.
very difficult.
Any
아니
n.
그러니까 더한다면 아니잖아.
For any n.
없잖아.
Any n is 1, 2, 3, 4, 5,
그러니까 어떻게
6.
구했어? 10 마이너스 1 하면 1
Yeah.
How many bits?
그러니까 저거 똑같은 거라고. 그러니까 여기서
N.
0부터 0부터 A까지 숫자를 구하는 건데 근데 빼잖아. 그럼 A지. A 플러스 1을 해야지.
No,
그러니까
if n is
A에서
2,
뭐를 뺀
well,
다음에
if
플러스
n
1을 해야
is,
된다고.
you know,
A에서
5.
시작하는 숫자를
Alright, I
뺀
think it's
다음에
bigger.
더하기 1을 하는 거야.
Yeah, if n is 121, there's only 7 bits. 121 plus 1 is 122.
그렇네.
플러스는
왜?
요거를 뺀다는
플러스
거를
1이 아니야?
더한다음에 여기 왜 없냐고
X잖아.
실종됐어.
네. A가
아니, 영이-
2는
0이잖아 저게.
아 그러니까 어차피 상관없다. 오케이. 올림피아.
N이 3이거나
아니.
A가 N이 100이야.
Okay. So, tell me now for any n.
숫자가 있는 건 아니야.
볼 N이에
Yeah.
그 N이 100이라고 하면 A 이게 이거잖아. A가 몇 번 들어가? 오잖아.
아니 N's
아,
very
우리는 몰라요.
important.
그러면 끝까지 해봐.
Okay, so we know that for n equals 2 to the a,
Yeah.
there's a plus 1 bits.
N 말도.
How does it change between 2 to the a and 2 to the a plus 1?
N 2.
Compare. What is 2 to the a plus 1 going to look like? How many bits does that have?
A plus 2 beats.
Yeah. So it's going to have a plus 2 bits, right? And this has how many bits?
A plus 1 beats.
Alright. So, everything in between. What does that have?
N 플러스 2?
A plus 1 beats.
Yes.
응?
Because it's changing. This is all zeros. These all go to ones. And then you get to a plus 1. And then it's all zeros, and that's 2 to the a plus 1. Everything in between is a plus 1 bits. Okay.
이거 맞잖아.
Now, I want you to find a form with relation to n. And here's a hint that log base a of b equals c means that, what? Tell me.
A to the C is B.
나 천재야. 아직도 해야 돼.
There's my hint. I want you to come up with an expression in terms of n.
하늘의 제한.
축하.
하늘 전체 한지.
전체
You know what is 제한?
제한.
Destruction.
Destruction genius.
Disaster.
제한.
Disaster.
네. 포기하세요.
기억 안 나.
이거 사용하라고요? 이거
빙수 먹고 싶다. 빙수.
빙수.
맛있다.
Serving.
갑자기 서울이 먹고 싶어.
설빙.
Serving is
아,
delicious.
인절미
좋아요.
빙수. 굿.
어우,
인절미
싫어.
빙수.
너무 지겹잖아.
인절미.
예.
완전히 지겹던데.
맛있다.
난 딸기.
저그 강릉에 갔을
나
때
팥만 싫어.
인절미
너무 지겹을 것 같아.
먹었어요.
무슨
그 유명한 빵 먹었어요.
where?
강릉.
강릉?
뭔
강릉빵?
빵이지?
국화빵?
그러게 강릉 무슨 빵이지?
아니 몰라요. 그냥 먹을 그
What flavor? 인절미 flavor?
인절미랑 그 안에 단팥이랑 크림 있어요.
Maybe
I know that, but I don't know what's
앙금빵인데 앙금빵.
몰라요.
I
방금
maybe.
너무 좋지 않아?
So 아이돈이 붕어빵에 아이돈이 팥빙수에
붕어빵? You don't eat? 안 먹어?
only supreme flavor.
cream.
아.
I love 빙수.
But what I hate about sorbing is it's only for 2 people. Only couple.
아.
어, 안 돼, 안 돼.
Why don't you eat whole thing?
너무 simple. I hate how in Korea there's not enough 혼밥. They need more 혼밥.
아, 혼밥.
혼밥?
I always alone. Okay, anybody get the right form? Did you
이건가?
get it?
준이 이건가?
I think about it.
유튜브 기사 식당.
너무 졸려요.
Why is a log base A O D
A가
C
B잖아.
is hint?
아닌가? A가 2잖아. 그리고 B가 C잖아. 아니 B가 A가
A is 2. 아.
비킨.
A네.
2 to the something is B. 2 to the A is N.
Maybe I should have used a different letter than A. Let's change this. Let's say log base. Okay. Log base B of C equals D
Oh.
means that B to the D equals C. My hint is B equals 2.
B가 2라고요? 엄마? 어머나? 아니겠네.
Oh my gosh.
B equal 2? Yeah, so what does that mean? So
What? No.
log base 2 of C equals D
Yeah.
means that 2 to the C equals D.
But
I want you to tell me how many bits are in the n sequence.
아.
But I think 2 to the D
D is
is
D. 2 to the D.
Yeah. Thank you.
You're welcome.
Okay, so my hint. I want you to tell me the number of bits in the sequence for n. We got 2 to the D equals C.
A.
What is n?
N은
N equals
2 to the A.
A.
how many bits are there?
N plus 1. A
A
plus
plus
1.
1.
Yeah.
Alright, 2 to the D equals C.
D plus 1.
와,
Right?
맞춰야 되나?
Alright, well, here's the thing. You need to get it in form of n, right? So what is n?
N.
Right? I want the number of bits. So I want it to be D. So yeah. So what is n in this equation? What is n?
C.
Yeah. And I want the number, I want the number of bits. Right? So what if we go back? Go backwards. Try going backwards.
Back to the future.
A
So we have some 2 to the D is A, right?
Yes.
Alright, go backwards to the log equation.
Log base B of n is A.
Log base what again?
848.
Log base B.
No.
Log base 2.
Yes, where did my mark?
Log base 2 of n is A.
Why?
Hooray.
Alright,
혼자서
so
뭐 하냐?
so we have log base 2 of n
Is A.
equals A if n equals 2 to the A. Alright, so what's the number of bits?
Plus 1. A plus 1.
Yeah, so what's our number of bits in terms of n?
8 plus 1. 2A only.
What?
What's our number of bits in terms of n? We have A plus 1 bits.
Yeah.
This equals A. How many bits do we have in terms of n?
A minus 1.
Oh,
What?
A plus 1?
A.
A plus 1, but we don't want A. We
One?
don't know what A is. We don't know what A is. We only know n.
And is natural number.
Alright, we're gonna add 1 to each side.
저기 A가 있잖아.
Log base 2 of n plus 1.
It's A plus
A.
1.
This is the number of bits if n equals 2 to
I
the
know.
A.
알고 있었어.
Huh? What?
잖아. 왜?
I don't know.
Okay,
Yeah.
we just showed if n equals 2 to the A,
Yes.
then log base 2 of n equals A.
응.
We know that we have A plus 1 bits.
Yes.
So we have log base 2 of n plus 1 bits because this is equal to A, so we just add 1.
A가 A 플러스 1 되려면 그 옆에다가 플러스 1을 해줘야지.
And log base 2 of n equals A, log base 2 of n plus 1
Yeah.
equals A plus 1.
And A plus 1 is n.
Number of bits.
Yes.
So this is the number of bits in terms of n.
Well, yes. Oh.
Yes. But that's
Interesting.
only if n equals 2 to the A.
그러니까
So, what is the general form? This is only if n equals 2 to the A. So what's the general form?
Log base 2 of n plus 1.
But that's a problem because
이거였나?
it's not always a power of 2,
그냥
right? So what if
크게 돼.
그 N이요?
2 to the A less than or equal to n less than 2 to the A plus 1? How many bits are there?
2 to the A plus 1 minus 2 to the
몰랐어.
Plus 1.
How many bits are there for in between?
내가 제일 큰 A.
A plus 1.
Yes.
그럼 여기서 A가 플러스 이거 되려면
Okay.
여기서 양쪽
We've got A plus 1 bits in there. So it's the same as this, right?
플러스 1 해주면 같지. 그러면
It's the same as this. Same number of bits.
이거다.
Alright, so the number of bits for any n
이거다라는 거야. 그렇기 때문에 이렇게 나온 거야.
equals what?
A plus 1.
아 뭐야? 얘기를 해줬어야지.
Oh, I'm really confused.
지 위에다 쓰는 거?
Okay.
Can you summarize your...
Okay. So,
떨어졌어? 2는 여기다 쓰는 거야?
alright.
여기다?
So if n equals 2 to the A,
이거 진짜 쓰면 돼.
we have A plus 1 bits. Okay? N equals 2 to the A plus 1, A plus 2 bits. Alright.
Yeah.
2 to the A less than or equal to n less than 2 to the A plus 1. How many bits?
Oh?
오 마이 갓.
Wait a second.
캔트. 수 없다.
How many bits? Go wait.
1.
Yeah. No.
2 to the 8.
Eh?
Okay. It's less than this. It's in between. It's in between these two, right? It's in between. So this is A plus 1. This is A plus 2, right? So we've got something where we have 2 to the A right? We have 2 to the a here, we got 1, and we've got a bunch of zeros all the way down to 2 to the 0, right? Sorry, 2 to the a minus 1, right? Alright, what's 2 to the a plus 1? We've got a 2 to the a plus 1.
A plus 1. 8.
Yeah, it's a plus 1 because everything in between is going to have the same as this. Okay?
Oh, really?
Well, why can't it go here? Because this is the smallest possible with a plus 2 bits.
Yeah.
Because we can't have this power of 2, so it has to be, we just make some of them 1s and stuff. Yeah. Right?
Yes.
Okay. Cool. So, we know that if, say that n equals 2 to the a. Okay. We want to find what a plus 1 is in terms of n, right? So f of n, right? So we take the log base 2 of n equals a.
No, base 2 then A, yes.
So log base 2 of n plus 1 equals a plus 1.
Yes.
This is the number of bits. So our number of bits equals log base 2 of n plus 1 for n equals 2 to the a.
Yes.
Okay. So this is our answer. But the problem is we've only handled the case where n equals 2 to the a. What about for some number like 37 or 121 or 41? How do we know the number of bits?
Nearest to the something. Alright.
So log base 2 of n rounded to what?
To nearest.
To smallest, yeah,
Yes.
to smallest, to rounded down to nearest. Rounded down means you're going down. Integer plus 1. Okay? That's our general form.
First, this one is integer.
Integer is like, positive integer is like 1, 2, 3. It has to be like a whole number.
Except negative.
Negative can normally be the case, but we're not talking about that here because we can't have negatives. We can't have fractions. Okay? And then you add 1. Okay. Everyone got it?
Teacher, why we add 1? Because a
you
plus
need
1?
the 0. Because this is a,
Why?
and then this goes to 2 to the 1. Right? This
Yes.
goes to 2 to the 1.
Yeah.
This is a, and then there's a 0. That's
A
1.
plus 1.
Yeah.
Okay.
Okay. Alright. So, if I give you n equals 287,
Oh.
how many bits?
Two to the a, so 9 bits. No?
Nope. Yes.
Yes.
9 bits. Why?
2 to the 8 and plus 1.
2 to the 8 equals?
Nearest integer is
What's 2 to the 8?
2 to the 8 is 256.
Yep.
And
So, log base 2 of 256 equals?
equal 8.
Alright, and then we add 1.
Oh.
Okay. log function that determines the number of bits, right?
로그
이게 로감수라고?
뭐야 로그 펑션.
쌤 너무
오.
아 짧게 쇼트.
와우.
wow, 뭐?
in Korea we learn 지수함수와 로그 함수인 second grade or third one or first grade or 마지막 수 in high school.
You learn this?
its name is 지수함수는 로그 함수. So the name of subject is log function.
Log function.
This is
쌤 릴렉스.
와.
비웃는데? 눈에 비웃는 거 의심.
Why?
Wait, this is a math class, right?
Yeah.
Oh.
Why you laugh?
why you're laughing?
No.
We learn too much things.
No. Just the name of the class is weird.
너도 name of class, but one of the 과목
On the subject.
You said the log function is the name of the subject.
in mathematics like everything blah 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 and log function.
Low function?
Log.
Log? Oh
이거-
god!
근데 이거 가사 몰라. 근데 찾아보니까 안 나와.
I heard something totally different.
공지랑 공지인데 그거 나오는 거.
뭐?
그거 진짜 나오긴.
잘못
Your pronunciation 발음 안 맞았어. 다른 거 들었어.
더 신경 나오는 거랑.
근데 이상하게.
방금
웃겼어.
멈추면 안
진짜.
돼. 혹시 몰라 다 얘기할 수 있잖아.
Okay, you learn log function, right?
Yes.
You know log function.